Okay, so the first thing you're going to want to do is go to Prusa's website to download the slicer, and this is going to be necessary to get any of the G code that you're going to sort of feed into the 3D printer. And these are drivers. You know, stay up to date with those if in case you have troubleshooting issues, you might need to update drivers. But here we find the actual links for downloading the Prusa slicer on several different operating systems. And when you import a project, you probably won't have the native file formats, so you'll want to import as an STL, for example, if you're working with SolidWorks. And what I'm showing here is how you could generate supports automatically. There's a built-in function in the print settings tab, and yeah, you're going to want to turn on support material, and you're also going to want to turn on auto-generated supports. Technically, you don't need support material on because it's included in auto-generated supports, but we'll come back to that. And so when we turn that setting on and then slice the object, you see it's predicting errors. When we slice the object, we now see that there's a toolpath outside of the print area, which means it would go like off the print bed. And the reason for that is because the default setting is to have a skirt loop, which sort of outlines the perimeter of the object. And if we turn that off, if we set the number of loops to 0, then our entire print should stay in the print bed if you've designed it properly to be able to actually print. Although I would always recommend that you try to only print small to medium things. We shouldn't really force the printer to go out towards its limits. Once you export, or once you slice, we see we have auto-generated supports, and they look pretty good, but if you're not entirely confident in their actual stability or how much they would help, you can always create your own custom supports. And again, here, when we import the STL from SolidWorks, it's rotated in such a way that it's too tall for the actual printer. So I went ahead and laid this thing sort of on its back so that it would actually fit. And so back in the print settings tab, we can turn on generate support material, but we'll turn off auto generate because we want to create our own supports here. And the way you would actually go about creating that support is to right click and then go down to add support enforcer. I like to use box. It's convenient, you know, we're already working in rectilinear coordinates, and you can stretch and squeeze and move it anywhere you want along the entire print bed. Don't worry about sort of going beneath the bed. It'll only slice what's above the bed. But again, as I said, you can make it any size you want. I really like using the cubic one. You can also copy paste. So on the right, you'll see that we now have 2 generic box objects, and those are our 2 support materials so far. You could rename them so that they have unique names if you wanted. Here I'm just saving so that I don't lose any progress, especially if you're making or adding a lot of supports. You would hate to lose your progress. And after I slice, after I slice, you see that it doesn't actually take into consideration the entire support. It'll sort of infer what's actually necessary. And now, after I added a few more supports, we see that we have another toolpath outside of the print area error. So again, this is the default skirt. You can save settings that you prefer, but I'm going to go ahead and turn the skirt height to 0, as well as the loop. You could turn the loop to 0 if you wanted. Especially on sort of curved edges and things like that, the skirt height will try to support that curve. So just be wary of the type of object that you're trying to print, but especially be wary of the different default settings. Yep, and now turning the skirt height to 0, we don't have that toolpath error, although I would always recommend that you try to print only small to medium things to avoid that sort of error and to, increase precision. And when you're happy with the supports that you have, I prefer to save the G code with a date so that if you're making incremental improvements on the design. This is a Prusa i3, and we use a Prusa slicer, so everything is obviously compatible. Never move that screwdriver. We have wires going under this acrylic pane. I didn't build this. The captain before me built it, Roger Black. What a guy. Cool guy. I think I'm just going to start another wheel today. This wheel, I forget how long it takes. I can check it if I want to. But the G code is already exported to the SD card, so that'll make it easy. Scrap box, and it's kind of stuck because the print bed is so cold. You can see the print bed and the filament temperature. So press X and click in on the knob, sorting files, info, preheat, and this up here, this is ABS filament, so depending on the filament you require different bed and extruder temperatures. There's the extruder. So now we're heating the bed up, and the whole point of this box is to reduce ambient energy loss to surroundings. So close the box when it's heating. We do have aluminum flashing, so maybe that'll be enough. Careful, the bed's still pretty hot. Hey! This is a wheel. Load filament. Now if the filament wasn't loaded, you would press it in, hit load filament, the extruder would heat up, and you have to select the filament because the filament will require different extruder temperatures. Preheating the extruder, and there we go, that's ABS. Press the knob to load filament. Alright, I'm going to press that and you're going to watch this. Yeah. Filament extruding with correct color. It is. We want to clean the extruder tip before we start a new print, otherwise it'll mess up. So this should be satisfactory. So there. I wish we had a brush. Maybe I'll buy a little brush for the print bed. And so now, click in, print from SD, and we want hydrogen fuel cell wheel ABS G code. Dead heating. If you want to print a new file, you'll have to save the G code on the SD. You can see it right there. Pretty easy. Well, you notice that it says 2 hours and 19 minutes for the full print. You see that with the extruder at temperature, we're getting a little bit of leakage. Yep. Okay. Calibrating. This is not a comprehensive calibration. It will do this at the beginning of every print, just identifying the boundaries of the print bed and midpoints. And then it will print a test. there's a little bead at the beginning. And if this goes well, then I think I should be good to go and come back in 2.5 hours. That looks accurate. So I'll wait for the entire first layer to go down, and then I will leave if I'm happy with it. If you saw a bead like that, sometimes the printing of the second layer will mess up, in which case the best fix I really know of is just quitting the print. It's just to click X again, and restarting the print. I'm really not an expert, but yeah. Bye! Oh, that's hot. Hot, 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 hot. Never do that. I'm cutting that out.